Okay, hi guys, I'm back for another video. I know it's kind of awkward that I'm wearing the same outfit 2 days in a row, so I thought I'd do something a little different with my hair. So also, I was just downloading that last video, and there's a bunch of weirdos that make comments on my other videos that's so strange. Like, who are you? But in case you're watching this one, I just want everyone to know that the Giants won the World Series again! Woo! So, way to go, Giants! I hope you guys had fun at the parade on Friday, and let's get back to work. Okay, so today we are going to talk about graphing y is equal to secant x, and we are also going to graph y is equal to cosecant x. Now, these are really weird graphs. So, if you think about it, like, almost like I want you to take out your calculator and graph it and just see what they look like and just take a little second and be like, oh my gosh, what is that? It's so weird. So, if you were thinking about it, maybe you already did, you probably already did play around with it a little bit over the weekend because you knew what was coming. Pretty excited. But let's figure out how to do it by hand because it's actually really, these are just as easy as graphing sine and cosine. So, if we think about graphing secant x, we know that secant x is the reciprocal of cosine. So I know that this is really equal to 1 over the cosine of x, right? That's how we started off, that's how we defined it. So all you need to do is just graph the cosine function first. Okay, so that's easy. So we know that cosine has a period of 2 pi. I'll break the period up into 4 parts to find the zeros, the maxes, and the mins. And I know that it oscillates back and forth between positive 1 and negative 1. And cosine starts at a maximum. Well, maybe I'll do one over here too. 0, negative 1, 0, positive 1. And then maybe if we're going to go back one more here, and then we'll do negative pi over here, and the cosine of negative pi, let's see, it's negative 1. So when I sketch my cosine graph, it looks something like that. So lightly do that with your pencil. Don't make it a really big dark line because we're actually going to erase this in the end. So if you guys, oh my gosh, just wrote it with your pen, don't freak out, we'll talk about that later. So sometimes I even just do this as a dotted line because this isn't really part of the graph. This is just going to help us graph the secant graph. Okay, so I graph that, and then I just need to think about the fact that secant is really the reciprocal of cosine. So that means that I can find reciprocal values at 1. Okay, let's start there. So now in a different color pen, I'll go through and graph the secant. So the reciprocal of 1, that's just 1, so that's actually in the same spot. The reciprocal of negative 1 is negative 1, so secant goes through that. Here, so these positive ones and negative ones, those don't change. But here's where the interesting thing happens. Right here where the cosine is equal to 0 at these points. Now that's going to be in the denominator, right? And so if I take this and I plug it in there, I'm basically dividing by 0. And remember, from when we graphed rational functions and then we graphed tangent functions, anytime you're dividing by 0, that's undefined. So you put a vertical asymptote there. Oh my gosh. Okay, so these things are going to have an asymptote everywhere where the cosine is equal to 0. Okay. So now I also need to think about this. As a number is getting closer and closer and closer to 0, the y values here are getting closer to 0. So what's happening, if my value is, let's say, 0.1, or we can also write that as 1/10. What would be the reciprocal of 1/10? So if this is what the cosine is equal to, then the secant would be equal to the reciprocal of this, which would be 10. So that's getting to be like up there pretty high. So even if I get closer to 0, like if the cosine of some angle is equal to 1 over 100, then the secant of that angle would be equal to 100. So that y value is getting really big. So as your y values get really close to 0 right here, if you're talking about the reciprocal function, they're getting really close to infinity. So what's happening, now I'm just going to erase this because I don't want it to interfere. I've used you for all I need you for, cosine. Get out of my life. Now I'm going to just say, okay, and also if I look at this back from how we were thinking about graphing rational functions, I have a 0 here, I have a point right here, and I don't have any zeros that are crossing through here, so the only way to do this would be make a parabola that goes in the opposite direction. Make a parabola that goes up. Make a parabola that goes down. Oh my gosh, it's so weird. It's just a whole bunch of up and down parabolas all over the place. Crazy! Okay, so what we did was, all I did is I just sketched the cosine graph first, and then I just add all the maxes and the mins. Those are basically the bottoms of these parabolas. And then where the zeros are, those are the asymptotes, and then I just sketch a whole bunch of parabolas, positive and negative, and make sure that they don't cross over the x-axis. That's not so hard. So let's try graphing the cosecant function. So I know if I want to graph y is equal to cosecant x, that's really the same thing as 1 divided by the sine of x. So I'm expecting to look something like this, the one that I just graphed, except that it's probably just going to be shifted a little bit, just like the sine and cosine are pretty much the same, just shifted a little bit. So I'm going to start off by graphing the sine function. So here's 2 pi over 2, 3 pi over 2. Uh-oh, someone's coming in. Oh, it's a churny. Come in, I'm making a video. Come in. It's locked. We have visitors. Hey, everybody, look who's here.
And math. I think your ponytail.
Hi. We just failed another stats test. Keep going.
Now I have an audience, so I feel like I'm a regular teacher. So I'm going to graph the sine function, so the sine starts at the origin.
That's not your hair, is it?
I think it's so pretty.
Is it ratchet?
No. Did you get a new phone?
Stop it, please. I think it looks so cute. Wait, let's watch the sine graph.
Oh, I hate pre-calc.
Okay, so here's your sine graph. And of course it's going to go on forever. So just like we did in the other graph, the reciprocal functions is going to have, these values are going to be exactly the same. Boom, boom, boom. And then what happens to the reciprocal of 0?
I have no idea. But this
Tangent lines.
is really important. Learn it.
Tangent lines, what are these things?
Parabolas.
Asymptotes.
Oh! All right, so I'm going to put in the asymptotes.
Will you send me this video after?
Nice job.
And then I'm going to go back and erase this sine function. So that's why you do it very lightly with your pencil. I know erasing is a lot easier on the whiteboard. And then I'm going to do that parabola down, this parabola up, and this parabola down, etc. So that's all you have to do. Just start off by graphing this, and if it's shifted or anything, so like if I wanted to graph y is equal to 3 times the cosecant of 2 times x minus pi plus 4, it looks like, that's a weird ass. It looks like it would be hard to graph, but I would just start off by graphing the sine of this exact function, and then just put the parabolas on the tops and the bottoms of the graph. And don't forget about the asymptotes.
Yeah. wait, look from the end of your
I thought sine had an E in it.
Let's all smile at the camera.
phone?